Dear students, I am K. Kavigan, working as Assistant Professor in Department of Biomedical Engineering at PPG Institute of Technology, Coimbatore. In this video, we see about the working principle of X-ray tube. So, X-ray tube used in many medical applications for viewing the bone structures or functions of internal organs. In this video, we will see about the working principle in detail with animations.
Production of X-rays. The lab setup shown here was designed by Coolidge, and hence it is called Coolidge tube. It contains a highly evacuated glass bulb containing a cathode, which is a tungsten filament, and anode, which is a target made up of metal of high atomic weight. The pressure inside the bulb is maintained at 10 to the power of -6 millimeters mercury. When the cathode is heated by passing a current through it from a low-tension battery, it emits cathode rays. These rays are nothing but electrons. The filament is surrounded by a molybdenum cylinder, which is kept at a negative potential to the filament. This repels the electrons further, and hence the electrons form a fine pencil beam at the center of the cylinder. This pencil beam is also accelerated by the cylinder towards the target. The target is made up of a copper block in which a piece of tungsten or molybdenum is fixed. High thermal conductivity is used to carry away the heat generated to the cooling setup. Here we use copper, which is a good conductor of heat and can take the heat away from the molybdenum metal towards the water cooling system. The target is also tilted at an angle of 45 degrees, causing the electrons to hit at an angle. This will produce the X-rays almost perpendicular to the electron beam. A very high potential of 20 kV is applied between the source and the target. Due to the high potential difference, the electrons are accelerated towards the anode and it hits the metal. When it hits, the kinetic energy is transferred to produce X-rays. The intensity of the X-rays depends on the number of electrons striking the metal target. So, if we can increase the rate of electrons emitted by the filament by increasing the current flowing through the filament, then we can increase the intensity of the X-rays.
X-ray technology utilizes high-energy rays that can pass through certain body tissue and create imagery vital to diagnosis and treatment. The X-ray machine is composed of an X-ray tube that contains a pair of electrodes or conductors called a cathode and an anode. The cathode is a filament that releases energy with the introduction of an electrical current, much like that of a light bulb. The cathode energy is released in the form of electrons. The anode, located on the opposite end of the X-ray tube, is a disc made of tungsten, a material that attracts the electrons. When the electrons released from the cathode come in contact with the tungsten, they release energy in the form of photons. These highly energized photons are channeled through a lead cylinder and a series of filters, creating an X-ray beam. The X-ray beam is a high-energy beam that can be absorbed only by dense body tissues, such as bone. During an X-ray, a radiographic film is placed behind the patient, and the patient is placed between the film and the X-ray machine. The X-ray machine then focuses the energy beam at the specific area of the patient's body. As the X-ray energy passes through the patient's body, the photons of the beam reach the film and cause a chemical reaction. The areas where X-ray energy passes through the body become black, while the areas where energy is absorbed by the bones appear white. This process produces a radiographic, which is commonly referred to as an X-ray.